So let's see how adding works in this coupling machine model of fractions. We've seen adding of certain coupling machines already. For example, the coupling machine that turns 1 into 3, that is the fraction 3 over 1. We can add it to another coupling machine that takes 1 as an input. And well, it's quite obvious that the total is a coupling machine that takes a single input and returns 7 copies. So it's 7 over 1. We can modify this a little bit by, for example, asking what if we don't present a single copy, but let's say it's something that takes 2 copies and returns 3, and here we have another machine that takes in 2 copies and returns 4. So it's 3 over 2 plus 4 over 2. And it's quite natural to see that, well, the division here doesn't really matter to the total result. If we insert, say, some variable a here, we get 3 copies of half of a, and here we get 4 copies of half of a. In any case, the sum most naturally is, again, the sum of the results, so 7 over 2. But what happens if we don't have the same number of inputs? So, as an example, let's take 5 over 6 and then add minus 3 over 8. How can we add this? Well, we kind of have to deal with these inputs, these denominators that are not the same number. But we can make them the same number by expanding. We are completely free to say, no, we don't want 6 inputs, we want twice that number, say, that is 12. And of these 12 copies, we retain 10, so we double the output as well. Well, 12 is still not compatible with 8. Maybe we need more here, so let's not take 8, but double that. So we have effectively turned this into 10 over 12, and this is minus 6 over 16. Well, we still need a little bit more here, and you probably have guessed already that we need a denominator of 24. So now we have 24 boxes here, 24 boxes there. So we need to double that as well. So we have 20 over 24, and here we have 3 times the original number of outputs. So it's minus 9 over 24. And now we can add. Now the inputs are compatible. We can put them together and get, well, 20 boxes here, 9 anti-boxes there, so the sum is 11 over 24. And that's how adding and subtracting fractions work. To finish, let's take a look at the algebraic formula for adding fractions. So in all generality, we look at 2 coupling machines. One takes as input b and as output a, and the other has the input d and the output c. And now b and d, they are not the same number of inputs, but we can turn them into the same number of inputs by expanding. So we expand b with d. Since we don't have any information about b and d, we just need to choose some common multiple. It doesn't have to be the least common multiple. So without any further information, we take the common multiple, that is the product. BD. So we expand this with D, and also, of course, expand the output. This is AD. And this gets expanded with B. So we also get BD inputs, and we get BC outputs. And now adding just means putting these together like this. So the final result is AD plus BC over BD. So this is how adding fractions works. Subtracting, of course, is now also in the bag. There you go. Beautiful.